All right, so let's work through some Ferris wheel application programs. So in this one here, we have a Ferris wheel which has a diameter of 520 feet. And we're going to break that apart to find its radius, which its radius is going to be 260 feet. And the highest point it reaches is going to be 550 feet off the ground. So the whole entire Ferris wheel will equal 550 feet. And let's just wrap up our whole entire figure here. So that means this bottom section, we get that by doing 550 minus 520, which will be 30 feet for our base of my Ferris wheel or a platform. And then the last piece of information we're going to want to know for our graph is going to be from our midpoint of, or the middle of our Ferris wheel itself, the wheel, and that to the ground. And so that would be our radius plus that bottom section there. So 260 plus 30 would be 290 feet. So this is going to represent my low point being 30. That's the lowest point in the Ferris wheel. The middle point being 290. And then the highest point off the ground being my 550. The next thing we're going to look at is my one rotation taking 30 minutes. So if it's 30 minutes, again, I can split up my 30 minutes into 4 different sections in my circle because we're going to assume 1, it's traveling in a counterclockwise direction, and 2, it's traveling at a constant rate. So we're going to start at 0. We're going to divide 30 by 4, so that'll be going by 7.5, then to 15, then to 22.5, and then to 30. So it says we're boarding on the ground, so that means we will be boarding when t equals 0. The height is going to be 30 feet off the ground. Then we hit our midpoint because we're now going to go up to our middle height being 290. We go up again, we hit our peak, which is 550. Then we start going back down to our midpoint at 290, or our midline. And then we end back where we started at 30. So if I connect my dots here, my graph would look like this. And that would be just one cycle being represented there. So I'm going to take this information and go ahead and do an equation to represent this model. So we start, if our midline here, we can draw that in. If our midline is there, we're starting at the below our midline, which means this is not going to be a sine function or sine equation. This is going to be a cosine equation because cosines start either at the top or at the bottom. But because this one is starting at the bottom, it's going to be a negative cosine. So y is going to equal some type of negative cosine. And we have to figure out our amplitude, which is going to be our a value, which is also going to be the same thing as our radius here. Our radius is 260, so a negative 260. Again, we said it's going to be a cosine of. Now we have to figure out what our b value is going to be. So our b value is based off of our period. Our period is one rotation is 30 minutes. So to find that, we find b is 2 pi over b is equal to 30. If I multiply both sides by b and then divide both sides by 30, that will give me 2 pi over 30 equals b. So my b is going to equal pi over 15. So I'll have pi over 15 times x plus my vertical shift, or my midline, which is 290. So this equation right here would represent my scenario going on with my Ferris wheel. This same process can be repeated for other questions, so let's go ahead and let's not do number 6. Let's do number 7. First off, we're going to take out this section right here. You start at the bottom of the Ferris wheel. It doesn't, not about that part. But a maximum point is going to be 15 meters off the ground. Our diameter of my wheel is 14 meters, with 1 revolution being 10 seconds. And we're going to board at a 3 o'clock position, which is going to change a little bit this time. A little bit of something this time. So Again, my maximum point here this time, label that, is going to be 15. My diameter is 14. So that means it's going to be split into 7 and 7, which means that this platform here is only going to be 1 foot off the ground, or 1 meter off the ground. And that means from my middle of my Ferris wheel circle itself to the ground is going to be 8 feet off the ground. So let's label these, my lowest point being 1, my middle being 8, and my highest point being 15. This is going to take 10 seconds, so I'm going to split that into 4 different sections. So 0, 10 divided by 4 is 2.5, so 2.5, 5, 7.5, and then 10. This time here, it's telling us we're boarding at the 3 o'clock position. The 3 o'clock position is going to be right here. So if I'm boarding there at 0 seconds, I'm going to be at 8 meters high. And again, we're assuming we are traveling counterclockwise. So we're going to be going up, and I'm going to hit my 15 next at 2.5. Then I'll slowly go back down. At 5 seconds, I'll be at 8. At 7.5 seconds, I'll be down at 1, and then back up at 8 at 10 seconds. So this one will look like this. And again, sine functions are ones that start in the middle. As we can see here, this one does start in the middle, so we're going to have a sine function. And this one is also going to be a positive sine because of the fact that it goes from our middle to our high point. If it went from our middle point to our low point, then it would be a negative sign. So we'll start here. Y equals our amplitude. So my amplitude here is going to be 7, my radius, times sine. Now let's go ahead and figure out what my b value is for this one. So this time I'll do 2 pi divided by 10, which is pi over 5. So I'll have pi over 5 x plus my midline, which is 8. On questions like this, let's just make sure we pay attention to things that are going on here with our position. So again, we started at 3 o'clock, which is going to be meaning we're going to start at our midline, and then we're going to be going up because we're going counterclockwise. In an example like number 8, I'm not going to work through this one completely, but if I'm starting at my 9 o'clock position here, I'll start at whatever my midline is. And again, I'm going counterclockwise. So this time, though, I'll be going down. Because again, counterclockwise. And then I guess with this example here, if we're starting at the top, we're starting at our top value here. And then we're still going counterclockwise, and we're going down to our midline. So that is how we would graph and create an equation for one of my application problems regarding a Ferris wheel. The process works pretty much exactly the same for every single one. Again, it's just very important to go ahead and A, make sure you're labeling your example of your Ferris wheel, and then B, drawing a good graph and converting your period to your B value.